Yes, truly, Professor Dr. Dolphy Gilpin, and we are on Mercury. Once again, let's highlight it on a partial portion of the periodic table. We're atomic number 80, Mercury, atomic mass of, well, you're saying 0.6 there, but it's really 200.6. And beneath it, there is copperusium, and above it is cadmium, atomic number 48. But you're focusing on Mercury, atomic number 80, and atomic mass of 200.6. We'll take a look at some of its isotopes, isomers, and allotropes. Okay, let's first continue with our notes in Mercury here. And we look at some reactions here in Mercury. Mercury reacts with the halogens to form dihalides, chlorine, bromine, iodine, and you know the other halides, acetine and fluorine. So it reacts with the halogens to form dihalides. So what you have, Hg plus F2 will give you HgF2, which is a white solid. That's the dihalide. HgCl2, Hg plus Cl2 will give you HgCl2, and that is also a white solid. Hg plus I2 give you HgI2, which is a red solid, and Hg plus Br2 give you HgBr2, mercury bromide, or dihalide, dibromide, which is also a white solid. And here we have mercury with oxidation state of +1 and +2. So I guess when it's used as a dihalide, we'll be getting the +2 oxidation state. So mercury can also react with organic compounds to form organomercury, and that is when we get that famous most toxic substance, methyl mercury. The organomercurial substance are highly toxic. Hydrargyrium, that is the olden name, or the name from which Mercury was derived. But Mercury is one of the fastest planets, and because of the high mobility in this liquid metal, it was named Mercury. Continuing with reactions here, 2Hg plus O2, that is mercury reacting with oxygen or with air, at 350 degrees centigrade, we get 2Hg plus O2 yield now 2HGO, which is a red solid, that is mercurous oxide. And after 300 degrees centigrade, and if you heat it more to like 400 degrees centigrade, what we have, the reaction is reversed, and it's now separated back. The HGO goes from this compound of mercury oxide to get back mercury and oxygen. So that's a very peculiar thing. We heat it to about 300 degrees centigrade, and the mercury and the oxygen form mercurous oxide, but above 400 degrees centigrade, it reverses itself and decompose back into oxygen and mercury. And this decomposition was very important in the discovery of oxygen as an element by Joseph Priestley and Antoine Lavoisier. It was a famous name, but we knew this from back there in high school chemistry. Antoine Lavoisier and Avogadro's number, and Joseph Priestley. Avogadro, Antoine Lavoisier, and Joseph Priestley. Here we have some more reaction here. Hg plus Cl2 plus more mercury plus Hg will give you calomel, which is methyl 1 halide. So that would be methyl 1 chloride. So you could have Hg plus HgBr2 plus more mercury will, following this reaction, will give you Hg2Br2, which will be mercurous, mercury 1 bromide. And similarly, Hg plus I2 plus more mercury, heated at the correct temperature, will give you Hg2I2, which is the mercury iodide, mercury 1 iodide. Now, reaction with dilute acid, we have 2 mercury plus dilute nitric acid to give you mercurous nitrate. Plus hydrogen. So here it is reacting like those famous displacement reaction deal with the alkaline and alkaline earth metal. Mercury acting as a metal here, reacting with nitric acid, it displaces the H to give you the hydrogen, and then it forms the salt, mercurous salt, mercury nitrate. Likewise, Hg plus Br2 plus more Hg will give you mercury 1 bromide, which is Hg2Br2. And we could just substitute some X in the reaction for the halides here, and because all of them will react in the same way, with the same thing to balance the equation, we could just use X for halide, and what you get is dihalides, and in this case, when you add more mercury, you get the mercury 1 halide. So we'd have 2Hg plus 2 Rx yield now 2 HgBr2 plus HgX2, where X is the halogen. The Grignard reagent, we have that reagent in organic chemistry. HgCl2, very popular, mercurous chloride, which is I think it's mercury 2 chloride here. Or mercury 1 chloride. Okay, HgCl2, the Grignard reagent in tetrahydrofuran, THF. That's the shortened form of tetrahydrofuran. THC, sometimes that's tetrahydrocannabis, but THF is tetrahydrofuran. So that comes up with the reaction with mercury there and the Grignard reagents. RMgX plus HgCl2 give you RHgCl2 Cl plus now MgX ClRMgX plus RHgCl, which you know HgR2 plus MgXCl, which is the organomercury. mercury. So all of the organomercurous compound, HgBr2, HgI2, and all of that, we will expect it to be very toxic. But methyl mercury is known to be the most toxic. Methyl mercury, that will be the organomercury compound. Howard, you said that it has about 35 isotopes, and 7 of them are stable. And what about radioactivity? At least you know that they are observational uh, or predicted radioactive, uh, but they have not been tested, something like that. Extrapolatively radioactive, not been tested. All right, yes, that's our short introduction in Mercury. We could get more advanced into it. And further on down the line, we'll highlight one of our teachers back there at A level, advanced level in chemistry, but that's at the high school level, college level, high school and community college level. But that's to come. So that's our Mercury here, and we go on to another metal, probably osmium or iridium, but let's see.